Okay, it's now 10:01, so good morning, everybody, and welcome to the first of this Palo Alto Back to the Future webinar series. So this is a 9-week series where we're going to take a look back at technology, and we're going to look at how it's changed over time. And if we click forward, please, onto the agenda. We're going to start off with probably one of the most fundamental principles of how security should be implemented in terms of reduction of attack surface using App ID, and look at some of the ways that security has evolved. And Nimesh will be running us through that presentation. And then we've got a weekly agenda which builds on that content about how we layer in different portions of security to make sure that we can prevent cyber breaches, essentially. And we're going to culminate in a session on the 5th of July, where we will discuss how do we take all of those elements that we've covered over the past 8 weeks to build a zero trust policy or a zero trust strategy, and what the steps to do that are. In terms of the content, this content is technical. It's created by practitioners for practitioners. It's not intended to sell you anything. It's just for providing updates and information for you to adopt new technology into your business. In terms of interacting with the panel, so we have a panelists who can take your questions, so put your questions in the chat or the Q&A box, and the panelists will respond back to you in as near real time as we can manage. We're going to also run a quiz. So next slide, please, Nimesh. The quiz is on Menti. You can scan this now, but if you miss it, we will show this again later. So make sure everybody gets registered, and we can check the people joining okay. The quiz will be quite straightforward based upon the content that we've seen today, and there'll be some small prizes at the end. What we'll do is we'll announce the winner at the next session, but I'll re-go over that as we get there. So without further ado, no need to listen to me anymore. I will hand over to Nimesh, who's going to take you through how to mind the gap and ports and protocols and policies.
Thanks very much, Chris. So so mind the gap, ports and protocols to context-based policies. So today's session really is about why context is so critical for effective security, why App ID is the foundation for security policies, and also cover some of the tools available to you to help you implement application-based policies. Now, so before I sort of dive into the details, I just wanted to set the scene by giving you a sort of a quick potted history of firewalls. So typically during the 80s, networks started to become interconnected, and really it was around openness and collaboration between research institutions and universities, etc. And kind of the demarcation between networks were routers, and they dealt with that really well. You know, they'd run different protocols, they would hide broadcast domains, etc. And that was kind of okay. However, researchers really started discovering early intrusion into these networks, and I mean, some of you may remember there was the Morris worm that was able to spread across networks globally. And as these intrusions became more and more frequent, initially it was just for curiosity, but became then quite sinister. Essentially, it was an end to open network connectivity, right? You know, security was needed. So research was underway in the 80s to develop network perimeter protection. And, you know, 1989, the first packet filtering firewall was commercially available from a company called Digital Equipment Corporation. Some of you may know of that. You've been around in the industry a long time. And essentially, it was just a packet filtering firewall, right? It operated at layer 3. It'd look at IP addresses in the layer 3 header. It may look at port information and maybe some flags. And then based on that information, it will decide whether to allow or drop the packet, right? Some of the challenges with the packet filtering approach was that it was easy to just inject packets into the stream, right? Because there was no state-based control on those firewalls. And so one of the use cases really for the bad guys was it was quite easy to map out internal networks. To sort of effectively solve these issues with sort of stateless packet filtering firewalls, in 1994, we saw the first sort of commercial stateful firewall, right, that maintained state by inspecting essentially layer 4, right, looking at TCP messages, looking at SYN and FIN to establish when a session was started and ended, right? And so that dealt with some of the challenges that you had with packet filtering firewalls. Moving along, so what we saw, pretty much from the early 90s and 2000 was a proliferation of network security equipment, IPS, IDS, malware systems, and there was a thought really of putting all of those systems together. And in 2003, you had the concept of unified threat management. Really, the sort of challenges around that was, typically sort of early versions of UTM would have a blade-based architecture. So essentially, there'll be a blade for firewall, there'll be a blade for IPS, there might be a blade for sandboxing, and a packet would traverse for each of those blades for inspection, and multiple lookups, no context between those different blades, poor performance, and the systems were complex to manage with lots of GUIs for different elements. So whilst it was unified in terms of being in one appliance, it's still really just separate, discrete security controls working independently. Then in 2007, Palo Alto Networks launched the first next generation firewall that really solved the issues that you had with UTMs and stateful firewalls. So what's some of the challenges really with the legacy sort of layer 3, layer 4 firewalls? So back in the day, port was an effective way to determine what the application was, right? So you had port 80 for web traffic, port 21 for FTP, and that was fine, right? You could allow or deny traffic and say, yeah, if it's on port 80, I know it's web traffic, I'll allow it. By the way, cloud firewalls still use that principle today, right? They still operate at layer 3, layer 4. And, that's a technology, that we're using from back in the sort of late 80s, right? In terms of the principles of security. Essentially, move forward, and developers had figured out that you could start using port 80 and port 443, for example, to get applications deployed. And essentially, it was simple, right? If I needed to deploy an application and I knew a firewall was going to block it, I'd make sure that the application used port 80 or port 443 or any other port that we knew was always open on a firewall. And consequently, we've got these big holes now. The firewalls are thinking that they're blocking a specific application by looking at a port, but what they are doing is just letting a whole load of applications through. And some classic examples were Skype and BitTorrent was specifically designed to be able to bypass security controls in firewalls. And now today, we know there's something like, probably we've seen about over 50,000 applications that are using port 80 and 443. Now, I've covered the case that application developers are using existing ports to pass through firewalls, but of course, obviously the bad guys are using those same ports for command and control and to exfiltrate traffic. So the next generation firewall really kind of solved this issue, right? Specifically by operating at layer 7, providing visibility into the applications that were traversing the network, and then applying policy on the application that's being used. Application ID, or App ID, as a term you're familiar with, allows you to do positive enforcement while sort of providing the breadth and depth of control that you need in a security appliance, right? And then the focus really is to enable the right business applications and allowing granular control of those applications. So as you can see here, we probably want to allow all our business applications, we'll have policies to allow Office 365, for example, or Slack, but then we want to deny the bad stuff, right? BitTorrent and OpenVPN as an example. The kind of philosophy from a broader perspective that we have at Palo Alto Networks, and for those of you who've seen numerous presentations over the years from Palo Alto, this isn't new, right? We have 4 key pillars on how we build and develop our security capability. The first sort of pillar is having complete visibility of the traffic. Once you have that complete visibility, you can reduce the attack surface. Once you reduce your attack surface, you can then look at preventing any known threats that are potentially using those attack vectors or you're exposed with your applications. And then also, next stage is preventing unknown threats. And that's doing all those controls, visibility, all the way to protection consistently across all locations, whether in your headquarters, branch offices, cloud, whether you're mobile users and IoT. So sort of zooming in into what this means, and I'll focus on the sort of visibility side of this. What we want to do when we're gaining complete visibility is to understand every single application that's running through your network, who all the users are in your network that are using the applications, what's actually going through those applications in terms of content. So that could be files, malicious content, sensitive data. We want to know about all devices and endpoints. We also want to look at encrypted traffic, which is very important. I'll give an example later of why that is so important. We want to identify SaaS and cloud application. We want to also identify mobile users. Once we have that complete visibility of what's happening in a network, we can then reduce the attack surface. We can block bad applications. We can control which functions of an application we want to allow. We can block high-risk file types, for example, and we can check whether the users that are on the network are allowed to do what we think they're allowed to do, and also limit the devices by actually looking at the device capabilities and determining whether that's actually an allowed device or whether it's a bring your own device, for example, and should have reduced security, reduced access to your environment. So in terms of visibility being the sort of fundamental building block, what does it actually mean and what does it actually look like? Because I wanted to give an example of what visibility an next-generation firewall will give you, particularly our firewalls. So an example here is we see a user transferring 344K of data to a destination. In terms of a typical layer 3, layer 4 firewall, what we'll see is a source IP, a destination IP, and a port. So we'll have an inkling of where the traffic is going. We know it's port 443, so we can probably guess it's SSL. So by doing looking at a destination IP address, fairly simple, not rocket science. We can tell that that IP address belongs to a location somewhere in Canada. And then by looking at the URL, which is what the firewall's doing now, we can determine that it's actually a file sharing capability that's being used. By doing integration with Active Directory or a network access controller, we can figure out from the IP address who the actual user is. And by looking up group information as well, we know that user belongs to a group called product management, right? This is all being done on next generation firewall. By decoding the traffic flowing through port 443, we can tell it's SSL. Now, we determined it's SSL not by just looking at the port, but actually looking at the actual behavior of the traffic flow, right? We've also enforced the port, but the most fundamental point here is that we are learning what the application is by the data within the traffic flow. Because it's SSL, the firewall decodes the traffic and determines it's HTTP. And then from looking at the HTTP protocol, we determine the application is slide share. So as you can see here, from just 3 or 4 pieces of information and looking into the data stream, we've actually determined that who the user is, what group they belong to, what application they're using, and where they're sending where the actual destination is. But even going further, by looking at the details of the application, we can also determine what the function of the application is. So for example, here we can see that the actual user is uploading data to SlideShare. Now that might be okay. The final piece is the document called roadmap.pdf. So the question is this legitimate? It could be, it might not be, but at least you have enough context here to make an effective security decision. Right, so I want to jump into give you an overview of App ID. So what is it in a sort of nutshell, right? And it's a bit of a quick refresher, right? So it is the traffic classification system that we introduced in 2007. It has evolved over time, but the fundamentals of how it works pretty much haven't changed that much, right? It sort of determines what the application is, irrespective of the port or the protocol that's being used. And then it decodes the traffic using multiple sort of classification schemes. So application signatures, looking at the actual decoding itself and the application behavior all together to be able to determine the application. Fundamental pieces, App ID is always on, right? You don't need to specifically flick a switch to turn it on. It's always there and it's classifying traffic straight away as soon as you start creating security policies. And as and when we develop new App IDs, they're published to the system automatically, and I'll cover how often we provide those updates and how you can implement those. As Chris sort of mentioned at the beginning, so application ID is really the fundamental foundation for all our sort of security services that run on the firewalls. By sort of identifying the application, we can then detect the application functions and operations, and secondly, the firewall can apply an appropriate decoder to scan the content. Once we can scan that content, we can then apply threat prevention. So as you can see here, threat prevention is essentially IPS, IDS. We can do malware detection via wildfire and DLP as well. And all these detections are done in parallel. Okay. Now, as we saw at the beginning, we'll be covering each of these different topic areas in further sessions. Decryption. This has become more and more important over the years. So we actually, when we launched the firewall back in 2007, probably less than 50% of traffic was encrypted on the web. Now today, depending on which numbers you look at, it's probably 90 to 95% of traffic is encrypted. So decryption is fundamental to be able to get visibility into the environment. And an example of what with and without decryption, if you have a legacy firewall and we see this type of connection between two IP addresses, 443, we kind of know it's SSL just through the port number. We probably know it's, for example, here, Google servers just by looking at the destination IP. That's the visibility you get at there through there four. Obviously, with using next generation firewall, we'll be able to look inside the handshake and be able to see, actually, we know this is actually a Gmail application, right? Again, okay, it gives you a bit of context, but not a huge amount. By enabling decryption, we can actually decode further and see multiple applications. So we might see, well, obviously the base application, but somebody might be using the drive component of Gmail. They might be downloading and uploading information or posting. But obviously, from what you can see with the decryption, now allows you to get better control over what you want to allow via the Gmail application. One of the other sort of interesting use cases is around application control. We apply a positive enforcement model, as I mentioned before. So application by default, everything's denied unless you put in policies to enable applications. Now, you know, historically, if there was an application that had a characteristic that you didn't like, for example, you had a particular what I call a shadow IT application that allowed you to upload documents to it, the default policy, well, we won't allow any access to the application. But what if you could say, well, actually, if this application didn't have an upload capability, then I can allow my users to access it, right? So this is what having a granular sort of application control allows you to do. I can say, I will allow access to this specific application. My business is not really sanctioning it, but we want users to be able to use it because they need to work with third parties, but we will disable components of that application. So I might want to allow downloads, but not allow uploads. I don't want to post files. I want to control whether the access is the consumer or the enterprise version, and I want to block file transfer, etc. So this is the granular controls that you can implement for an application to allow more freedom for your users, but whilst maintaining your security posture. So I guess the question then is, well, this might look complicated, but how can I implement these policies? Well, it's actually fairly straightforward. The way you do policy constructs on the firewall does pretty much align very closely with the business logic you want to apply. The business logic will be, well, I want to allow, for example, a marketing team to be able to access certain social media accounts, and I wanted to inspect all their traffic for malicious behavior, and I may want to control what files they're allowed to use or what devices are allowed to use. I can create all of that in one single policy. Very straightforward, and even when I'm reviewing policy, I can see exactly what people are allowed to do, when they're allowed to do it, and what they're allowed to do. So very straightforward. Whilst we've been talking about implementing security controls and granular controls, the other sort of key aspect of the firewall is just the pure visibility and reporting function that you can get. So what I'm showing here is the ACC tab on the firewalls, but also on the panorama. So if you have panorama and using it, that's providing an aggregated view. What I can see in detail are all the sort of applications that are being used in the environment. I can understand it by the usage, who's using those applications, what the threats are that are carried by those specific applications, and the category of those applications. And you can zoom in and filter and get a really good sense of what is going on in the environment, and obviously generate reports that can be shared. The other aspect of this is you get instant visibility into applications that are running on non-standard ports. Very important. As you can see, people, we might have traffic masquerading as something else, trying to use ports to bypass it. This will give you a straight, clear view as to all your web traffic, for example, that you can see here that is running on non-standard ports, right? And it allows you to do further investigation and then determine whether you should allow that or deny it. Okay. So now I'm going to cover off implementation and tools, which is quite important. Right? It's like implementing application ID and application controls is slightly different to just implement port-based policy. So we provide a set of capabilities that simplifies the whole sort of deployment of application-based policies, but also how to sort of manage them as well. So in terms of just managing app ID-based policies, we have sort of several capabilities. One is application groups, which essentially allows you to be able to simplify provisioning of groups of applications into security policy. Application filters is almost like application groups, but gives you more of a dynamic approach, and I'll go into the details of that. And then probably one of the most sort of useful features that we have on the firewall that we introduced a few releases back is the policy optimizer that allows you to sort of tune your policies, or at least help you migrate to application-based policies and then maintain those policies. So with application ID groups, so they are static groups, and this is under the object tab in the firewall. So we have probably about 4,000 plus applications today on the firewall, and you may want to simplify provision of those applications into policies. So typically a security policy will have source zone, destination zone, and a list of applications you want to allow. Now, you probably don't want to keep going into a security policy to update the applications that are allowed. So the alternate, and sort of one of the best ways to do this, is to create an application group, and then within that group, assign all the applications that you want to allow. So you may have infrastructure applications, for example, as one group. So it could be NTP, DNS, etc. in one application group. Then you may have sort of sanctioned SaaS applications that you want to allow in a separate group. So you build those up into your different applications group, and then you attach the application group to security policy, so that when you then want to add or remove applications, instead of having to change the security policy, you just add them to the group. Okay, so that's application ID groups. Now, whilst application ID is static and it requires an administrator to sort of maintain that list, filters behave slightly differently. So they essentially create a dynamic list of applications that are based on a various set of characteristics or tags that are associated with the application. So an example may be, I want to allow business systems based applications, right? So I create an application filter that automatically selects applications based on a category called business systems. And so when we add new app IDs to the platform, if they have a category called business systems, they're automatically added to the security rule. Okay. Consequently, you can use that to also block certain categories dynamically in security policy as well. Okay, so that also creates a sort of broader set of security policies to allow more traffic, but then of course you can tune that later using the policy optimizer. One actually important part of application filters is tags. So this is something we introduced a couple of releases ago. On applications, when our application researchers are building up applications, they now have the ability to assign a tag to an application. Tag could have an application could have multiple tags. So an example could be an enterprise VoIP application, right? You may want to enable enterprise VoIP applications because your users are potentially collaborating with other users in other businesses that are using different collaboration apps, right? And you don't want to figure out, well, what are all those apps that other third parties are using, right? Well, you don't need to do that. We'll tag all enterprise VoIP applications, for example, with this tag, and then you can create an application filter that specifically only has enterprise VoIP applications in it. So again, as and when new enterprise VoIP applications are added to our application updates, they're also being picked up by security policy. Okay. So policy optimizer. So for those customers that picked up our firewalls or deployed them, many of you may have used that Expedition migration tool to be able to take layer 3, layer 4 rules off your legacy firewalls and port them over to the firewall. And then once you've done that, the next step would have been to start moving those towards layer 7 policies. Now, realistically, some customers have been able to do that over time. Others have maybe just stayed with layer 3, layer 4 policy. So to complement that, we developed the policy optimizer to help you migrate your current layer 3, layer 4 policies that you have in place on your next generation firewalls to layer 7 firewalls, and then also be able to fine tune those policies over time. So how does it work? So typically when you go to your security rules, you'll have a policy optimizer option. Now you may have a rule here called allow TCP 443 and 80. Pretty common. Now, as I said before, application ID is always running. So by choosing that rule in policy optimizer, we'll be able to see straight away all the applications that were running or allowed under that specific rule. And as you can see here, we've got a range of information when we last saw the application, how much traffic was transferred, etc. And what you can do is simply, if you agree, you can just tick all the applications, assign them to that rule, and now that rule has become tightened, right? It will only allow the applications that you have assigned to it. Okay, so it's a very simple way to go from a standard 443 port 80 based security policy to now a layer 7 based policy, right? So you can see here we've got a match usage option at the bottom, right? So you can have various ways to be able to assign those applications to the rule. The other interesting one is the removal of unused app ID. So it may be a case that you may have created more of a sort of a more promiscuous rule because you don't want to disrupt existing users. So you'll have a range of applications that are allowed. It may be based on application filters. And what you can see on that rule is the applications that you saw under there, but then you can actually see unused applications and remove those, right? So that's that tightening. You might even see applications that haven't been used for a long time, and then you can choose based on that criteria, remove those applications from the security rule. So this is a maintenance activity that allows you really to simply and easily clean up security rules that have too many excessive applications in them. So app IDs and the life cycle, this is quite important about how we deliver application ID. So where do they come from? So fundamentally, they come through dynamic content updates. You may be familiar with this. We do that dynamic update contents for a range of different components on the firewall for antivirus signatures, wildfire signatures, and obviously there's apps and the threat signatures themselves. Now, app IDs specifically are released every month. As a customer, you can request a new app ID for a new application that we haven't developed a signature from. And you can also create custom app IDs on the firewall. So if you have homegrown applications that you want to identify, you can use Firewall's inbuilt custom ID, app ID tool to build the signatures. So in terms of when those updates happen, specifically for app IDs, they will happen once a month, and it's usually the third Tuesday or Wednesday within that month. It can vary. We may, in certain cases, deliver an emergency update specifically out of band if, for example, there's a zero-day threat, or you have an application that may not be working correctly and we need to fix it before the next scheduled update. Content or application updates are provided in release notes in advance. Very, very important to read those release notes. They have a lot of information in them about the app IDs themselves. We've got some instructions there on how you can sign up for that, but it's essentially through, you can subscribe to app ID updates through Live Community. I'll give you an example of a release note here to show you what the type of content is. It's always important to bear in mind that application ID content updates are not necessarily always new app IDs. We may do different things. So as you can see here, there's a whole range. This is a recent release note, actually that's coming up for next week. So we can see here, I've highlighted some key points with expanded coverage for SharePoint, for example. So I think what that means is actually newer app IDs are being developed for functionality that already had an app ID, but we've broken it down a bit further, right? So new app IDs that potentially should be added to security policy, for example, for SharePoint. And a new example here is a brand new one is Bing AI Chat and Google Bard, right? Obviously, that's AI is a big thing at the moment. Chatbot, lots of users trying to access those, so we're keeping up by introducing new updates for those. And then we've got to update DNS over TLS. I've highlighted that because it was something that's been misidentified previously as DNS over HTTPS, so we've changed the actual app ID there. So it's important to read this carefully, because what you may find is when you do deploy the content update, stuff might stop working if you haven't anticipated what that change is going to be. Now, there's some tools to help sort of mitigate that. I'll cover that in a second. How you do the updates. So if you're familiar with content updates from the past, typically you probably would have done a sort of download and install, and it all just works transparent in the background. It's completely non-disruptive. It doesn't interrupt the operation of the firewall. But specifically with application updates, we over time have introduced sort of additional sort of controls to help you delay the deployment of those updates. So there's two sort of specific fields that you should take a look at. One is the threshold. So essentially what we're saying here is only download and then install the content update if it's been made available for more than 24 hours. Now, that's essentially giving you a buffer, particularly if you have mission critical applications that takes priority over security. You may say, right, I want to wait 24 hours, maybe 48 hours, maybe longer for other customers to use this capability. And then, you know, once it's been soaked by customers and I don't see any new content updates to emergency that contain an emergency fix, then I can go ahead and download and install this automatically. The other piece of this is allowing extra time to sort of review the new app ID. So not only do we have a timer to download and install, but once the download occurs, there's a period of time that you can have to be able to review the app ID notes, maybe make policy changes in anticipation of those changes, and then the install will take place automatically after the app ID threshold is expired. Okay. Slightly different to how content updates worked in the past, several releases ago. App ID filters select new app ID. So you may find certain occurrences that we may have changed an app ID to something else, which then might actually look like a new app ID. And if you haven't got a policy that sort of allows it, then you may see traffic that was legitimate and working in the past stop working. So what we do when we launch a new application, it is tagged as a new application. And so what you can do is create a security rule with an app group filter, new applications, so that if we do introduce new applications, and you don't, of course, have them in your security policy, or they're not picked up by an existing filter, the new rules policy will automatically allow that traffic, and then you have time to see, actually, am I actually using that app ID? If I am, then I can add that to an existing security rule. If I need it, or just remove it, right? You have about 30 days to do that, right? Because once the next content update arrives, those previous new app IDs are considered old and will start getting blocked. Okay. So yeah, so that sort of concludes my presentation. See, please feel free to ask questions in the chat window. I'll hand over to Chris.
Fantastic. Thank you, Nimish, and thanks for the detailed updates. So we don't currently have any open questions in the Q&A, but please challenge the team. They like to be challenged with difficult questions, and that's why they're here. But in terms of next steps and call to action, so we have camp 2, really. So if you're an existing Palo Alto customer, you have firewalls deployed, we want to drive the adoption of App ID because it leads to better security outcomes and better security policy by reducing attack surface. And we've got some tools that are available for best practices, so we can help you analyze the state of your deployment and where we can improve and harden the tool or the deployment or the configuration of the firewall. And within there's a whole plethora of recommendations that we can make, App ID just being one of them, but also user ID, any improvements we can make to threat prevention deployment. That tool is built into our AI Ops platform, which you can have a free trial. Just scan the QR code. You can request a 90-day trial. There's a freemium version of that as well as a premium version, so you don't have to subscribe to anything, but you can start to take advantages of the best practice assessment tool and look at how you can reduce your external attack surface. The second portion would be, if you're not a Palo Alto customer, you've never come across this before, we can help you analyze what you're seeing in your environment. And so we run something called a security lifecycle review, where we can provide visibility into all the applications that we're seeing on your network. We can highlight some of the risks that will be traversing your environment. We can do, if we have a decryption enabled, and we can get full inspection, or if we don't have decryption enabled, we can get partial inspection, as Nimesh talked about. But either way, we can start to formulate a view of what's happening on your network. So again, you can scan the QR code, you can request a security lifecycle review, and somebody from the sales and marketing team will get in touch to organize that. Okay, so we've had a question that will get picked up by the team, hopefully in the background, Deepak. So if that doesn't get picked up, we can answer offline. So moving on to the next webinar, we're going to build on what we just talked about. So we talked a lot about application signatures, but SaaS applications provide a very different challenge. The reason that they provide a different challenge is, firstly, they are prolifically generated. And so the way that we create an application policy doesn't necessarily change, but the way we detect the application has to change because we have to do it at scale. And so Sean Taylor, our technical specialist for SaaS and DLP, will talk you through how this layers on top of just straightforward App ID for the SaaS application controls. So that's the next session. We're going to move on to the next part, which is the quiz. So if you want to stop sharing, Nimesh, please, I will open up the quiz. For those of you who didn't catch the QR code, don't worry too much. I'm going to put that back up now. So I'll share my screen. So let me know if you see this in present mode.
That's good, Chris.
Fantastic. So if you register for that, give me a thumbs up to let me know you've joined. I'll give it a couple of minutes to let everyone in. I can see 14, 15 people joining. Okay, we'll give it a couple of minutes. Any issues, let me know in the chat, and we can try and resolve those. It's always good to experiment on a live webinar as well. This is a tool I'm not particularly familiar with, so we'll roll with it. Let's see how it goes. Okay, give it another minute. Okay, we're up to 32. Any more than 32? There we go. Still going up. Okay, we're at 37. Let's get started. So, premises of this game is quite simple. Multiple choice scoring is based upon a correct answer, but also the speed of which you answer your correct answer. So there's points for being fast on this one. I'm going to proceed to the next question. So hopefully, if you're all connected and ready to go, we'll get started. Okay. I say I'm going to get to the next question. Cannot move it. I knew this would happen. Let me just pause the share. Oh, love it. Team, we are having a disaster. My laptop is actually frozen. So can you even hear me?
Yeah.
This is typical. Never perform with live demos and animals. Let's see if we can get this going. Can't get this unfrozen. I would try and reload my browser and see if that will help. But at the moment, I'm a bit stuck.
Do you want me to run it, Chris?
Can you get into it, Nimesh?
Yeah, 1 minute. Let me.
Everything's frozen.
Oh no, well, someone else is presenting at the moment, so you've blocked me, Chris. So...
Let me just close my browser then, Nimesh, and you should be able to get in.
Yeah. Okay, can you see my screen?
Yep.
Right.
Legal from our deals desk folk. I mean, there is huge support right across with all the different speedboats. So if you think you need help, be greedy, shout for help, go and get the resource.
Thank you. Right, ready to go.
Okay, super. So let's give it a go. Nimesh, can you move the screen? Can you move it?
I can't do it.
All right.
Oh, here we go.
Here we go.
Here we go. Right. Ready to go. First question coming up. How is App ID enabled? Nearly there. Yes, right. App ID is enabled by default. Nothing to do.
Phenomenal.
Right. So who's on top? Hot. Well, it's pretty close at the top there.
Pretty tight.
Yeah, very tight.
Impressive work.
All right, question 2 coming up. I just developed a new internal app. Can I create an app ID for it? Nope, fairly easy one there. Yes, you can, using the custom app ID feature. Oh, still tight at the top. Oh,
Really tight.
Just got a slight edge there over Tom. Where can you quickly see if there are any port-based policy rules in next generation firewall security policy? A couple more. That's correct. Policy optimizer can be used to find port-based policies in your firewall. Oh, what happened to Hollow Hoop? Disappeared. Snuggles has taken the lead. Question 4. When decryption is disabled, you need to create port-based policies. True or false? False. Don't need to create port-based policies, right? Enable decryption and it'll be picked up by application ID. Okay. Very tight, 6 points separating Snuggles and Ribbit. And the Hustler's just there behind, another 13 points, right? 14 points even. Final question. You ready? How can you deny any current and new applications that don't have regulatory certification? Tricky one, this one.
Tough one.
A lot of reading to do.
Yeah. Good.
Very good. This was a kind of a sly one because we had a screenshot of applications and there was a screenshot that showed characteristic no certification. So some of your sharp-eyed viewers might have spotted that, but yeah, that's good. So,
All right, fantastic. So, moment of truth is we are going to announce the winners of this quiz next week. So we've been tracking it all the way through, but attend the next session, you will find out who the winners are. So as I talked about earlier, the next session will be covering SaaS applications and how we help identify and control those SaaS applications with Sean Taylor. But please feel free, send this registration and invite to any of your friends, colleagues that you think might find this useful. After this, we end this Zoom meeting, we will be publishing a bit of a survey, so feedback on the session, but also really keen to understand what you folks on the call would like to see next. So after this webinar series, are there any call or any topics you would like us to cover in more detail? Please put your input and your feedback in. But for now, that is it. Thank you so much for attending the session. Thank you so much for spending time with Palo Alto Networks. We hope you found it useful and you are free to go. Thank you.
Thanks. Bye.